In this video, we're going to talk about section 3.1, the determinant of a matrix. Let's start with problem number 5, which asks us to find the determinant of the given matrix. We're given a 2 by 2, 5, 2, -6, 3. We're going to denote the determinant by putting these straight lines that look like absolute value bars around it. And the determinant is going to be this first element, the elements along this diagonal of the 2 by 2. Let's just write it this way: 5 times 3, and then minus, multiply the elements along this diagonal, 2 times -6. So that's going to be 15 plus 12. That's going to be 27. So your formula, and it works only for 2 by 2s, is ABCD is equal to AD minus BC. You may ask what's going to happen when you don't have a 2 by 2. We'll get to that very shortly. But we're going to get to number 11 next. And we have a matrix that has a variable in it. That's the Greek letter lambda. Looks like an upside down Y. Lambda minus 3, 2, 4, and then lambda minus 1. And so when we take the determinant of lambda minus 3, 2, 4, and lambda minus 1, we get lambda minus 3 times lambda minus 1 minus 2 times 4. So we're going to have lambda times lambda is lambda squared. Lambda times -1 is negative lambda. -3 times lambda is -3 lambda. -3 times -1 is +3. -2 times +4 is -8. So we end up with lambda squared minus 4 lambda minus 5. Let's go ahead and clear the screen and move on to number 15. Number 15 asks us to find all the minors and cofactors of the given matrix. So let's give ourselves some space. We're going to need it. -3, 2, 1, 4, 5, 6, 2, -3, 1. So let's make a list here of M1, 1, M1, 2, M1, 2, M1, 3, M2, 1, M2, 2, M2, 3, and then M3, 1, M3, 2, M3, 3, where this is first row, first column. So if I eliminate the first row and the first column, what's left? That's going to be 5, 6, -3, 1. So that's going to be 5 times 1 minus 6 times -3 is 5 minus a -18. 5 plus 18 is 23. So now I can find the cofactor for M11. What I'm going to do is that's going to be -1 to the 1 plus 1 times M11. So that's going to be -1 squared, which is 1, times 23 is just going to be 23. So some of these will change sign, some of them will not change sign. If the to find the cofactor, if the sum of the row and column is odd, it will change sign. If the sum of the row and column is even, it will not change sign. So let's look at M12. So cover up row 1 and column 2. That leaves us with 4, 6, 2, 1, which is 4 minus 12 is -8. And so C12 is going to be -1 to the third times -8. That's a -1 times a -8 is a +8. M12, 4 minus 12, C12, 8. So M13 is going to be row 1, column 3, 4, 5, 2, -3 is going to be -12 minus 10 is a -22. And then C13 is going to be a -1 to the 1 plus 3 is 4 times -22. So that's a +1 times a -22 is a -22. M21, so if I eliminate row 2 and column 1, that's 2, 1, -3, 1. So that is 2 minus a -3. 2 plus 3 is 5. And C21 is going to be -1 to the third times 5 is a -5. M22. So if we eliminate row 2 and column 2, that's -3, 1, 2, 1 is -3 minus 2 is -5. C22 is going to be -1 to the fourth times a -5 is a -5. M23, if I eliminate row 2 and column 3, that's -3, 2, 2, -3. So that's going to be 9 minus 4 is 5. C23 is -1 to the fifth times 5 is a -5. M31. So if I eliminate row 3, column 1, that's 2, 1, 5, 6 is 12 minus 5 is 7. And then C31 is -1 to the fourth times 7 is 7. M32, so eliminating row 3 and column 2, -3, 1, 4, 6 is -18 minus 4, -22. C32 is -1 to the fifth times -22 is a +22. Then M33, we eliminate row 3 and column 3. That's -3, 2, 4, 5 is going to be -15 minus 8 is a -23, making C33 equal to -1 to the sixth times a -23 is a -23. So when we talk about minors and cofactors, and that being a way of expanding to find a determinant when we don't have a 2 by 2, this is what we mean by a minor and a cofactor. Now it actually gets a little bit easier than this. I'll do it this way, but I'll also show you the sign pattern and the other way to do it that you can just memorize the process for, not have to find all of these. This is nice when it gets bigger and you need to find these minors and cofactors to simplify things for yourself a little bit. So now let's go ahead and look at, that was number 15. Now we're on number, now we're going to actually look at number 19. We're going to finish the problem, and it asks us to did it ask us to find the determinant of that matrix? I don't think it did. No. So we're good. So let's move on and look at number 19. So let's find the determinant of number 19. And it is 1, 4, -2, 3, 2, 0, and -1, 4, 3. And I need to use cofactors to find this determinant. So let's go ahead and let's start finding. Let me just show you the process. So there's a sign pattern here that goes plus, minus, so on and so forth that way, minus, plus, minus, and it alternates signs this way, and then plus, minus, so on and so forth, minus, plus, keep going, plus, minus, keep going, minus, plus, keep going, and it just continues forever in all directions, right? Since this is a 3 by 3, I'm going to know that the sign pattern here is going to be plus, minus, plus, minus, plus, minus, plus, minus, plus. This has to do with the what is -1 to the n going to do in these positions. So this is an even power, this is an odd power, an even power, an odd power, an even power, an odd power, so on and so forth. So I don't have to really do the cofactor part. I just keep track of, is it the same or the opposite sign of the minor? So when I want to expand on a row or a column, it does not matter which. I pick the easiest for me. Probably pick something that uses this 0, and it's just as easy here, and I'll use the positive number. So 3 is in the negative spot, so that becomes a -3 times, and I'm going to cover up the row and the column that 3 are in, and that leaves me with 4, -2, 4, 3, and then I come over here to 2, that's in a positive spot, so +2, cover up the row and the column that 2 are in, that leaves me 1, -2, -1, 3, and then -0 times anything is going to give me 0. But if I wanted to cover up the row and the column just to show everything, 1, 4, -1, 4, but that's just going to be a 0. So now this is -3 times 4 times 3 is 12, minus -2 times 4 is -8. So it's going to be +8. It's 2 times 1 times 3 is 3, minus -2 times 1 is 2. So this is going to be -3 times 20 plus 2 times 1 is negative 60, plus 2 is negative 58. -1, negative 2, 3, 2, 0, 1, 4, 3, and a negative 3, 4, negative 2, 4, 3, plus 2 is 1, negative 2, negative 1, 3, and then 0 is going to be 1, 4, negative 1, 4. Don't worry about that. 12 plus 8 is 20. It's negative 60. 2 and 3 minus 2 is 1. So that's negative 58. Yes, it is. And then let's look at '25 next. 25 says x, y, -1, 3, 2, 0, 1, 1, 1. And we're going to I'm going to expand on that top row that has the variable. So that's going to be a positive x times the minor here, 2, 0, 1, 1. Then I change the sign here. This is a negative y. And that minor is going to be 3, 0, 1, 1. And then a positive -1. So that's -1. And that minor is going to be 3, 2, 1, 1. So that's x times 2 times 1 is 2, minus 0 times 1 is 0, minus y times 3 times 1 is 3, minus 0 times 1 is 0, minus 1 times 3 times 1 is 3, minus 2 times 1 is 2. That's 2x minus 3y, and then -1 times 1 is a -1. Looking for number 33 next, which is to use the method demonstrated in example 5 to find the determinant of this 3 by 3. This method only works for 3 by 3s. That's why we talk about minors and cofactors first. So 33 says 3, 0, 4, -2, 4, 1, 1, -3, 1. So I'm going to change that into a determinant. And I'm going to write down the first two columns again. I'm going to try my best to be neat here so that I can make diagonals here. So this is 3 times 4 times 1. And multiply like that. And then 0 times 1 times 1. And so when I go this way, I'm adding. So 0 times 1 times 1 plus 4 times -2 times -3. And then I'm going to subtract when I come this way. So that's going to be 0 times -2 times 1. And then minus 3 times 1 times -3, and then minus 4 times 4 times 1. So that's a 0, and that's a 0. 3 times 4 times 1 is 12. 4 times -2 is -8. -8 times -3 is a positive 24. -3 times 1 times -3 is a positive 9. And -4 times 4 times 1 is a -16. So I have a 35 minus 7 is a 28. Sorry, this is 30. What did I say? 35. 36 minus 7 is a 29. All right, the next problem is a calculator problem, so I'm not going to show you any work other than to say in 37, we're going to go into your matrix menu, create matrix A, which is going to be 1, 2, -1, 4, 0, 1, 2, -2, 0, 3, 2, -1, and 1, 2, 0, -2. And you're going to want to find the determinant, DET, of matrix A, and the calculator is going to tell you that that is 19. So there's no work to show for that other than to get it into the calculator. If your teacher tells you to not use the calculator for that problem, to do it by hand, I would recommend expanding on this column that has a lot of ones and zeros. That's to your advantage to do that. So take advantage of those ones and zeros when they're present when you need to use cofactor expansion. So that was 37. On to number 39. Is not a calculator problem. 39 says to find the determinant of this triangular matrix. So all we need to do when something is a upper triangular or lower triangular matrix is to just multiply along the main diagonal to find the determinant. So this is a lower triangular matrix here. You can see that all of the numbers that are non-zero are in that triangle down there. So the determinant of -2, 0, 0, 4, 6, 0, -3, 7, 2 is going to be equal to -2 times 6 times 2 is -12 times 2 is a -24. Let's look at number 49. And 49 tells us to find when this determinant is going to be equal to 0. Lambda is going to come back up here. And this is a very common situation that we're going to run into later, where you're going to have a determinant that has lambdas in it, and you're going to set the determinant equal to 0, and you're going to solve for lambda. So we're going to multiply along this diagonal. That's going to be lambda squared plus 2 lambda minus 2 times 1 is 2. Now, we cannot factor this, so there are no factors of -2 that add up to be +2. So I'm going to take this 2 to the other side of the equation and complete the square. So half of 2 is 1. 1 squared is 1. Adding 1 to both sides, I get lambda plus 1 quantity squared is equal to 3, meaning that lambda plus 1 is equal to plus or minus square root of 3, and lambda is equal to a -1 plus or minus the square root of 3. Two different answers for lambda. So I'll have a lambda 1 equals -1 minus root 3, and I'll have a lambda 2 is equal to a -1 plus square root of 3. All right. 51 says that I want to find the determinant of lambda, and then 2, and then 0. Row 2 is 0, lambda plus 1, 2, 0, 1, and lambda. So it's not lower triangular or upper triangular. I can't just multiply here. This is going to be set equal to 0. So I'm going to have to choose something to expand on. I like column 1 because it's got 2 zeros in it. So I'm going to write down my lambda, and the minor for that that's left is lambda plus 1, 2, 1, and lambda. So that's going to be lambda times the quantity, lambda times lambda plus 1. Let's call that lambda squared plus lambda minus 2 is equal to 0. So this factors into lambda plus 2 times lambda minus 1 is equal to 0. I usually like to write my lambda answers from smallest to biggest. So the smallest 0 here is going to be when lambda is equal to -2. My next biggest one is when lambda is equal to 0. And my third biggest one here is when lambda is equal to 1, that factor will be 0. So those are my 3 answers to number 51. And that's it for this video. We'll come back next time and we will talk about section 3.2, which is determinants and elementary operations. So elementary operations of determinants. See you for the next video.